This conference will now be recorded.
So welcome everyone to this SCLF webinar, and which is on invasive vegetation, and I'm happy to introduce our speaker today, who is Mark Prout from Ebsford Environmental, and I'll just give you a wee bit of introduction to Mark while he's getting his screen shared and stuff. So Mark is the Managing Director of Ebsford Environmental Invasive Business Group and has over 20 years of practical experience in the world of invasive species management. At Ebsford Environmental Limited, he's developed the Enviroscreen 20-20 TM into an economic and effective treatment for the removal of Japanese knotweed from developed land. In excess of 600,000 tonnes of Japanese knotweed contaminated soils have been screened and reused on site on some of the largest Japanese knotweed projects ever undertaken. So without further ado, I will hand you over to Mark for his presentation.
Hello and good afternoon. So this is all going to be a very strange situation for me because I cannot see you, I cannot obviously hear you. So essentially I am just a man sat in my own little room talking to myself. I will share the presentation, carry on, and hopefully you'll sit in and listen and enjoy. So invasive vegetation management. We actually made this presentation a roadmap to success before the term roadmap became popular, as is evident over the last few weeks. And we've set it out in a way to make it a route to show how and what the problem is, and looking at methods of treatment, legislation, and how invasive weeds impact upon development. So firstly, why are you here? Well, presumably you're all here to improve your knowledge on the topic, to escape prosecution for any potential invasive weeds that you may encounter on a development site, and ultimately to protect profit and your assets from any potential damage that may be incurred from these sort of species. A little dump truck travels along to define the problem. Well, Japanese knotweed is the premier plant species that everybody recognises and knows about, but it is identification being the key point that everybody needs to go through. So at different stages of the year, the plant looks completely different. Through the autumn, we have the dead, dying stems and the leaf changing colour. During the winter, the stems are all brown and it looks like a completely devoid plant of any life. Over the next few weeks, the ground will begin to be covered with nodes and buds coming through, and the rate of growth is exceptional, anything up to about 10 centimetres per day over the course of the next few months until the summertime when it produces flower. So just to broaden some of those pictures out there, a good example of some Japanese knotweed in the latter part of the summer, early autumn, where the leaves have all turned brown. As you see from the neighbouring trees, the leaves have gone as well. It's a very, very pretty yellow colour, yellow and orange, as the plant begins to take all the nutrients that it's gained over the summer months back down into the rhizome below the ground. So the stems end up being dried out and dead and very dense. These are all coming from what's referred to as a crown from the central area as the rhizome as it builds up. And in this picture you've got the darker stems as they are the years preceding this picture being taken, and then the lighter stems will be years before that. So you generally end up with 3 years worth of stems standing and still providing cover for the new stems as they grow. This is a nice little new bud coming through, very similar to an early asparagus, so to speak, almost spear, and as it grows along, it will grow, as we said earlier, there about 10 centimetres a day The growth is incredible. And later on, in the latter part of July, August time, the flowers come out. You've got lots of little tiny, pretty little white flowers that make the plant quite attractive, which ultimately is why it's been such a success. Now, library pictures of Japanese knotweed are all very well, but it's very rare that you encounter some of these plants in this way when you're out on a development site. So some further examples of what Japanese knotweed can look like. Here in the bottom left-hand corner and the bottom right-hand corner is a cemetery, I think it's over in Norwich, which has been historically treated with herbicide, and the knotweed now is only a couple of centimetres tall. But it's still there and present within the ground, and that is the issue. It does cause some damage to tarmac, which is a relatively easy surface for it to grow through. And in these circumstances, the plant can look fundamentally different to that which you would expect to see through a library picture or possibly an identification book. And then we've got the additional fun that there are 3 other versions of the main plant within this country. Probably between 80–90% of all the Japanese knotweed in the UK is Renutria japonica, formerly Fallopia japonica, but it was recently reclassified. And then we've got Renutria sacladensis, which is the giant knotweed, and this is an epic plant when you see this, because it will grows at similar speed, dies off in exactly the same way over the winter, but will grow anything possibly 3.5 to 4 meters in height in a similar sort of length of time. Very fortunately, when Japanese knotweed was brought to the UK, only the female of the species was brought in, and as a consequence, it doesn't spread via seed. None of the seeds there will be seeds produced on the plant, but it's generally because it's been pollinated with another species, and the crossbreeds don't tend to survive. So there is very little, if none, spreading of the plant via seed. It all happens generally by us in the transportation of soil and fragmentation of the rhizome. Ultimately, with the saclanensis version, there was a male plant brought into the country, and the cross between Renutria japonica and Renutria saclanensis produces a hybrid called Renutria bohemica, which is slightly in between the two. It's a little bit smaller, but causes the same problems, and is all covered by the same sort of legislation. And the final one, which in 20 years of doing this I've found twice, is the Renutria compacta, which is a garden cultivar, which has been used a few places about the place. So certainly large houses and historical properties would have some of this in the gardens occasionally. And this is quite a small plant. It's very bushy, and only gets to about 2 to 3 feet high. So on we go to the impacts. Well, obviously structural damage and stigma and a potential prosecution, and then a loss of biodiversity. We all like a structural damage picture in the world of Japanese knotweed. It does undoubtedly cause structural damage. There are options where potentially it causes harm. We've seen this on a regular basis. It's a very good example. It tends to grow along the easiest route that it can find. So in this instance, we have a few stems coming out the join in an asbestos downpipe on a building that's going to be demolished. And when we took it down, the entire downpipe was solid Japanese knotweed and stems that have grown up over a period of time. The treatment of Japanese knotweed causes issues to be able to identify it. So here we have some knotweed up against the fence. I can't point, but if this works, it's just there. And then some other invasive species, some buddleia and the normal plants that you would tend to find. But it does cause has the potential to exploit those weaknesses that are already present. So in this instance, we have Japanese knotweed that's been historically, probably concreted over when the buildings were initially created, and it's merrily grown between the joint between the concrete and the brick building for a number of years. Little to no damage to the concrete has occurred because there is sufficient room in the gap between the two to be able to grow. However, by increasing that gap, it is obviously letting water in and potentially causing harm in the future. So there was a recent study done on invasive weeds and how they impact and how they cause damage. So this is the top of the previous slide there with the downpipe, and the Japanese knotweed is coming out of the of the downpipe there. But this is ivy, and it's arguable to say that the ivy is equally causing damage to the building in this instance. So there's a cross between the two. Japanese knotweed, however, does it so much quicker. And this is one of our probably favorite photographs, is that you can make your own window box, so to speak. But this Japanese knotweed is actually growing up through the cavity of the building and then out through the felt roof at the top. So it does everything it can to get to light, and ultimately that's its aim, is to get to light, to be able to photosynthesize, do its plant thing, and create its sugars to be able to recharge its batteries for the following year. The biodiversity impacts of Japanese knotweed are that it just completely outcompetes other plant species, and it produces very little quality habitat for any of our native plant species or animals. The density of the stems prevents everything else from growing. So again, here you can see the green stems from the year of the photo being taken, and all the other old stems from previous years, out competing and out preventing light from hitting the ground there to allow anything else to germinate. The early growth is a good shot of the early growth, showing how the leaf matter on the floor prevents any other seeds from actually reaching the soil to be able to again germinate and produce any form of plant. And the density of the larger stands of Japanese knotweed do not allow birds to nest or anything else to grow. When you get in amongst a stand of this type of thing, there is very little else there. You might find the odd spider, but there's no slugs and snails. There's nothing that tends to eat Japanese knotweed. At this stage in its lifetime, it's actually quite nice in a stir fry, but by the time you've got here, it's a bit tough, and it's not even suitable for us. And then in the latter part of the year, it produces its flower, and this also has a biodiversity impact, as you get pollinators coming to the Japanese knotweed rather than going to the native plant species and pollinating there. So there's always been a lot of news about Japanese knotweed, and the Daily Mail is a great source of information, as we all know. But the headlines that we see about Japanese knotweed plays on the name, and we've had some fairly high-profile cases over the last couple of years with Network Rail facing problems where the Japanese knotweed has been coming across from their boundary into other land and affecting the value of properties. And they've lost several cases, which has left people into a position where there are more and more of these legal events taking place and following through. So what is the legislation? Well, the main piece of legislation that affects Japanese knotweed is the Wildlife and Countryside Act. And in 2010, this was reviewed at a time when a number of other plants were added to the list. But the definition of Schedule 9 was clarified, because it has always been the case that it was an offence to allow the plant to grow into the wild. It was an offence to allow it to grow into the wild. But there was no real definition of the wild within the law. So this clarity was tried to be made to say that if it was growing beyond the landowner's control, it would be considered to be growing in the wild. So the other legislation that affects this, the Environmental Protection Act, putting an onus on people to control the material and making it a controlled waste. There's various other mentions of it within the Food Environmental Act. The control of pesticides obviously influences the chemicals that can be used on the plant and how it can be controlled. Landfill licensing is an issue there because some of the landfills are not able to receive Japanese knotweed, so we have to be wary of where it can be taken and how it can be used. And obviously within that and within the environmental permitting regulations are all the waste transfer requirements and everything else. The Antisocial Behaviour and Crime Policing Community Act, people are saying that you could get an ASBO for having Japanese knotweed, and it's not strictly true, but there is a situation now where the council can issue a requirement to control Japanese knotweed on land and a few of the other species as well. But it's more of a piece of legislation for plant species that aren't quite in the wild yet, but may be imported and could then be potentially causing a problem in the future. We do a lot of screening, which we'll move on to in a moment, which is covered by some of the mobile treatment licenses and on-site incineration, which is also under a permit regime. And then we have the final one, the environmental permit regulations, putting an onus on the duty of care for waste transfer and making sure that we have a duty of care for the traceability of waste that's produced. So looking at management, there's several different options for the management of Japanese knotweed. And I think the key thing that we've learned over the years is that knowledge is everything. Knowledge that is gained over experience and time allows you to be able to provide a suitable solution which works in conjunction with the timescales for the development and also anything else that's happening on site. So one of the things that we often promote is the trade associations. We have to be looking at making sure that you've got a contractor that is suitably qualified and has got the backup to be able to do the work. And also when the surveys are undertaken for the invasive weeds, timing is everything because you have to have that ability to be able to recognise the plant at different stages of the year, at different stages of growth. Accuracy of information is all important to be able to cross-reference the areas of knotweed with the development plan, and obviously ultimately that you need to have that protection of warranty at the end of the work to show that the work has been done to a suitable standard and there's an insurance policy in place to cover any occurrences of regrowth. And obviously within contaminated land, you guys will all know about the complications that come with other contamination. It's a regular occurrence, not on every job, but it's a regular occurrence that where there's Japanese knotweed, there's asbestos. Other contaminated soils, we've undertaken works previously where we've had Japanese knotweed growing beside old former fuel tanks, and the ground is saturated with oils, yet the Japanese knotweed is still able to grow within it. And then we end up with a perfect storm of oil contamination, Japanese knotweed contamination, asbestos contamination. The soil can't be processed and retreated or cleaned because of the knotweed or the asbestos. It can't go into certain tips because of the oil. It all becomes very, very confused, and trying to find a disposal point for this sort of material can be complicated. Ecology often influences obviously bird nesting. The one few thing that does happen with the stems and the knotweed stands is you will occasionally get a blackbird nest growing in it. It doesn't support very much, but occasionally you get a blackbird nest around the outside. So clearance of the stems is all important. And obviously water tables and beside rivers can complicate matters and limit your ability to either excavate or treat with herbicide, depending on what influences there are downstream from that area. We've recently had a project where we've been refused the permission to spray because there are a series of cress beds downstream of the site of knotweed. So therefore they don't want any potential for any herbicide to get into the water and cause an issue within that situation. And obviously trees, TPOs and root protection zones prevent the excavation of material in close proximity. So the trade associations, we've got the Invasive Non-Native Specialist Association and the Property Care Association. The two have very similar standards. We have a code of practice for both. The INSA standard is slightly more robust than the PCA. The PCA have slightly more members and is probably orientated towards the domestic market as much as the development market. So for properties that are requiring a remortgage or purchase that are established, as opposed to those where we are building on brownfield land, which require a sort of a site-wide warranty. But both of these are very good accreditations, and we would highly recommend that any works that's undertaken for Japanese knotweed should be done by one of these approved and accredited contractors. So looking at surveys and the seasonal considerations, obviously is when and how. Nobody knows when you're going to start a new development site, but the earliest point to look for Japanese knotweed is when you've decided to do something. It's very important that the earlier you can get an idea of what is there and where and how and what you need to do, the easier it is to design a method that will take account of all of those aspects, rather than it being the excavator driver on the first day of work saying, isn't that Japanese knotweed? That's when it tends to become very, very expensive. So Japanese knotweed is not the only one. We've rambled on about that for the duration, but there are other plants that need to be considered, and we need to look at the format of how that survey is presented. So it's very important to get that accuracy and consistency of information. So we tend to undertake surveys with GPS. This is a project we're working on currently, where they're actually putting in a new rail line. So we've been able to interpret the data that has been provided by the client there in the red boundary line, showing the route of the new line that's coming through there. And then the areas of green are Japanese knotweed that are outside of that section. The areas of orange are knotweed that will need to be dug up and treated within the section. It's not just Japanese knotweed that you can cover, but you need detailed information on anything and everything that's present. And so here we've got a lot of giant hogweed, another species that we'll talk about slightly later on. Floating pennywort is also covered by the same legislation, but most of these plants, they don't cause the same structural problems, so they don't tend to gather the same sort of opportunities, and that they're not highlighted by the press in the same way as Japanese knotweed tends to be. But it's important to make sure you know exactly where everything is, and then cross-reference that with the information you've got for your development of the site. And it's not just pre-plans that need to be done, but there's also post-plans that need to be accurate and correct. So this is an example of a development where we've got 5 properties there in the back. This sort of plan is needed to be produced now to be able to provide a warranty. The only properties here that will be warranted, that will qualify for a warranty, are those that are within 7 meters of the Japanese knotweed area. Anything outside of that area is not deemed to be, there's no risk to be insured within them. So only the properties that are within that 7 meters. So accuracy of that information is key to be able to provide the right and suitable warranties. The best warranties and the ones that are recommended by RICS and accepted by UK Finance are those that are issued by the PCA and INSA. They're backed up by a PI insurance, which gives cover even if the contracting company that undertake the work cease to trade. And it's very important that you go down that route of an accredited company, because within these scenarios, if the company that undertakes the treatment ceases to trade and you have to call upon the warranty, then the warranty is a simple process to go back to the accreditation firm, either the PCA or INSA, to be able to call upon a new contractor to undertake the work. So what can be done with some of these plants? Well, Japanese knotweed is again the key one that we'll look at now, and a couple of three different options for treatment. Screening is the system that we've developed at Ebsford over a number of years, where it became a source of frustration to me personally that we were excavating so much soil that there was nothing very much wrong with it other than Japanese knotweed was there. And it was all being taken off to landfill and disposed of, and there seemed to be no real reason for that. So I called on my farming background, where I'd spent many a year picking potatoes and sorting potatoes on a potato harvester, and realised that we could generate and create a machine that would allow us to separate the rhizome from the Japanese knotweed from the soil in a similar sort of way. And that's exactly what the Enviroscreen does. And we've got a couple of machines now that do this at different stages or different sizes of volume, depending on how much is present on site. So we need SI and reports on this. And obviously, clay is not a suitable soil for breaking up in this way. It needs to be a friable soil. But we've got to a system now. We've got a zero to landfill that we can actually screen the knotweed out, give the soil back for reuse, and then incinerate the rhizome on site. It can be done at various stages and at various sizes. So this is a unit. This is actually a Terex 1400, a fairly big screener. So some of you will have used those before or seen them. On this particular site, we had about 14,000 tons of soil to process, and this was the right sort of equipment for the job. We generated and created our own picking stations and processed that soil over a period of just over a month and a half. Once you've processed the soil, we end up with 3 stockpiles. And sometimes the clients will have us amalgamate stockpile 1 and 2 for reuse. But stockpile 1 is essentially all the larger stones and bricks and concrete blocks. Stockpile 2 is similar to a type 1 sort of material, suitable for reuse on site, as is stockpile 1, but sometimes stockpile 1 needs to be crushed if you're re-engineering back in. And then you've got stockpile 3, where you've got a topsoily like material, and it's commercially unviable to try to remove the fragments of knotweed from this material, because it will grow from a piece the size of your little fingernail. So it's just not possible to remove it in its entirety. So we know that we remove the viability from stockpile 1 and stockpile 2. That can be reused on site without any controls. Whereas stockpile 3 has those smaller fragments in, but having done some research on how the plant grows and understood what happens with it, we know that if we can cap that material off with a 600mm layer of clean material within the site and generally within the POS, there is no opportunity for that plant to regrow. It just doesn't have the energy within its rhizome to be able to get back up to the surface. So some of the smaller streams. So this is Serena the screener, and she's a relatively new addition to the family. So there we are, screening. This is a job down in Plymouth, and it shows how it separates out the soil and then produces just this mesh of rhizome, which is removed and placed into bags and either removed off site or incinerated, depending on the regulations in the local area. This is a site in Station Road in Normanton, where we did a massive site for a housing developer. Again, intense Japanese knotweed throughout, and this process was screened. And I think it's just over 5,000 tons of material screened on this development site. Herbicide treatment is also an acceptable policy to undertake, and but it's very important to understand that it all depends on what happens to the area where the Japanese knotweed is growing afterwards. If you are planning to disturb the ground in any way, herbicide management is not the process that can be undertaken. Herbicide is primarily for those sites that are near the river or in a hedge that's not going to be destroyed, or in an area where there's going to be no development or construction whatsoever, because the herbicide works on the premise it's been taken into the plant. It takes 3 years to undertake that treatment. You tend to treat 2 to 3 times per year throughout the summer months when it's growing, and as time goes by, the plant itself shrinks and becomes much and significantly smaller in size, and then you continue to revisit until you're happy that there's no further growth. Disturbance of the soil in those locations can lead to viability, because you end up disturbing rhizome from a depth that can come back. But the way to deal with that is that if it's going to be in an area where there needs to be some sort of landscaping, it is okay to put soil over the top of treated Japanese knotweed without disturbing that surface. So there are ways to work with it. We've done some herbicide management on this particular project where we had Japanese knotweed and masses and masses of giant hogweed, and this was controlled with multi-season eradication. I think we're now into our 4th year of treatment there, and there's very little growth returning. And the most expensive method of treating Japanese knotweed is to excavate and simply remove to landfill. And this process, like I say, is one that is often used because there hasn't been the right preparation at the beginning of a development or the beginning of a process to sort of explore all the alternatives that could be undertaken. And ultimately, it's just been a case of it's all too late, it's holding the job up, let's get it in a lorry and get it off to the landfill, and then everything will be okay. But we are in that situation. Then, like I say, that often people don't take account of the fact that if you remove 20 lorry loads of material from a development site, you've then got a very big hole that you need to then deal with before you can do anything else. So it can be very expensive, and obviously the other contamination within the soil also affects the viability of this process, the acceptability of the material at landfill, and where you can get that material disposed. And we do the odd one. This is a site down in Yapton, down in Southampton, near Southampton, where a lot of material was dug up and removed, and a lot of asbestos was also found on this site and removed at the same time. Viability of a system is also very important. We do occasionally undertake cell burials, and this is a picture from a cell burial that had been undertaken and placed in the wrong location on a development site. And we were actually employed some 3 years after the cell had been built and the knotweed had been contained within a membrane. And a cell burial is essentially digging a large hole or creating a bund, and then covering the material and encapsulating it within a geotextile that is sealed and welded shut. And you can do that provided you're 7 meters away from your site boundary. You can do that sort of operation, weld it shut and keep it airtight and contained, and that's where your knotweed will remain forevermore. So this picture was taken on day 1 of pulling back the membrane that had been ineffectually, or on the cell that had been ineffectually installed. It had actually been installed in the footprint of a road, because somebody done something wrong with a laser level, I think. So it had to be moved. So it was incredible to see this, because it's very rare that we've actually dug up an area of knotweed that's been buried for such a long time. But as you can see, it was quite merrily growing underneath the membrane, bearing in mind that on top of this membrane there was about 500 mil of soil, so it was encapsulated, completely airtight, no light entering into the system at all. On day 3, the rhizome began to grow, and the knotweed was there and quite viable and alive. And by day 7, there was identifiable, quite obvious plant ready to go and ready to grow off. So this it still amazes me, after all the time that I've been doing this, that this stuff had been encapsulated with no air, no light, no nutrients, nothing else other than what was around it for 3 years. We ultimately had to encapsulate this again. We had to move it so that it was slightly out of the footprint of the road, and excuse me, and then re-encapsulate it with a stronger membrane and cover it again with the right quantity of soil to properly encapsulate the material. So hopefully that is the problem solved. So you've got an early survey, a registered contractor, correct warranties, everything in place, some detailed GPS mapping and GIS, the way it's presented, and then at the end of everything you need a compliance and a completion report, and it's all systems go, with a great little graphic there. So looking at some of the other plants, what's in your garden? Well, I mean, there's loads of invasive species out there now. The Wildlife and Countryside Act covers about 50 plants. A lot of them are aquatic and don't cause problems with construction, but would cause other issues with they're there because they're ecologically a problem. There's always something happening, because we transport plants all over the world and bring them in from lots of different areas, and we only find out that there's a problem generally when it's too late. So we've got there on the left, we've got some Himalayan balsam, some water primrose, and some parrot's feather, and a few of these are covered now. Giant hogweed. The only other plant that was originally on the Wildlife and Countryside Act alongside Japanese knotweed is giant hogweed, very prevalent in Scotland, where there's some massive stands of this plant. Giant is, by definition, the reason it's called it is because it is absolutely massive. It will grow 2, 3, 4 meters in height, generates a flower. Each one of those white flowers, anything up to 1,500, 2,000 seeds per flower head. Masses of proliferation of the plant. When you have it, you tend to have a lot, and its main problem and the main cause for it to be on this list is the significant harm that it causes if you touch it. Now, we have a common hogweed in this country, and that too will cause a degree of burns, but it tends to be only for those people that are sort of very allergic to the material, whereas giant hogweed, prepare yourselves now for this next picture, causes severe blistering of skin where it's touched, and this is it's phytotoxic. It actually bonds to your DNA and then causes the same blister and coloration of the skin over a period of time, and repeat actions even when it doesn't, even when you don't touch the plant afterwards. So it causes a massive problem. Himalayan balsam is another plant that's very popular alongside the rivers and streams. Thrives in those situations. It's the tallest annual plant in the UK, and grows again 2-3 meters in height, but is also very happy at 18 inches in height. It produces this flood of purple flowers, which ultimately turn into seeds. Each seed pod will have 8 to 12 seeds within it, and then it has the capacity to be able to catapult these seeds anything up to 7 meters away from the parent plant. So this method of spread is incredible, because it takes in all the water courses and then off it goes and floats off downstream, and then regrows in the areas where it floods and the seeds are deposited. But again, this plant is covered by the same legislation as Japanese knotweed, and any soil, therefore, that contains any part of the plant would be classified as controlled waste and subsequently could only be removed to landfill or dealt with on site in one of the encapsulations or burial methods. Balsam is there because of its biodiversity impact. Primarily, it outcompetes other species along the riverbanks and causes populations of beetles and insects and bugs to decline. But it also is it's pollinated by the bees. The bees tend to love this plant, and you end up with that preferential pollination again. And the things like the purple loosestrife and the lilies and things like that don't end up with the attraction that they would normally get. And one of the last slides we've got here is the definition between horsetail and mare's tail. We often get calls. We've got mare's tail coming through the tarmac, and it's not mare's tail. It is definitely horsetail. Mare's tail is an aquatic plant species. It doesn't tend to cause too much of a problem, to be honest, but it's completely different. It looks similar, but is completely different to the horsetail, which is an archaic plant. Goes back to the Jurassic period. There's very few brontosauruses about now to be able to nibble this down and keep it under control, but it will cause problems with tarmac, and we often have this with housing developers where the specification on the tarmac of driveways is never the same as you would expect within a road, and therefore because of that weaker material, this plant will merrily grow through it within the first 18 months of the development. So I hope you've enjoyed that today. That is the summary of everything. I'm going to escape now so that I can see if anybody's still here and see if there's any questions.
That's great. Thank you very much, Mark. I'm just going to stop the recording there. That was great.